Hello guys, welcome to today's video. In this next 20 minutes we are going to break down one of the most important concept in modern AI engineering, that is RAG architecture, also known as a Retrieval-Augmented Generation. This architecture is the backbone of accurate AI chatbots. Enterprises assistance documents based on QA systems, the large scalable knowledge tools. And also in this video, by the end of this video, you clearly understand the how RAG works, why it is invented, and every internal component, the retrieval pipeline and the generation pipeline, the complete end-to-end architecture. Let's get started. Firstly, what is RAG architecture? RAG architecture is a system designer where retrieval model and generation model works together to produce answers. Like traditional LLMs are rely on their internal training data. This causes outdated knowledge or hallucinations, inability to access their private documents. RAG solves these problems by adding a retrieval step before generations. The system first retrieves relevant documents and then uses them to generate accurate grounded responses. In short, RAG equal to search plus language generations. So why RAG needed? RAG is needed. LLM alone cannot reliably answer from custom documents, stay up to date, handle the domain specific knowledge, generating factual accuracy. So these are not only in LLMs. So LLMs are cannot reliable. So RAG provides fresh knowledge and grounded answers, no retraining requirements, strong hallucination controls, and enterprise level accuracy. So this is why nearly every real world AI solution uses the RAG today. In RAG architecture, there are mainly two topics. One is the data injection workflow and another one is text generation workflow. Let's discuss data injection workflow. It is a storing knowledge. These are in this data injection workflow have raw documents. These are the original files that contains the information. Think of PDFs or Word files or websites, manuals or textbooks. This is our knowledge base. The AI does not understand these files automatically, so we need to prepare them. And it has an embedded model for documents. To process these documents, we use something called embedding models. These models convert text into numbers. So we have a doubt. Why numbers? Because computer understand numbers better than plain English. These numbers represent the meaning of the text, not just words. And it has another function called embedding vector representation. Once the embedded model processes the documents, each paragraph or chunks of the text becomes a vector, a big list of numbers such as 0.12 or 0.89 or something. This vector represents the semantic meaning of the text. Two similar paragraphs will have similar vector numbers. And this data injection workflow has storing data. It is called storing vector storage, vector database. Now comes an important part, the vector database. The special database stores all embedded, unlike normal databases, which match exact words. A vector database matches a meaning. Let's go through an example. If the question is how to restart the phone, they will match documents that talks about rebooting, switches off and on or restarting, even if the words are different. There are different types of a vector database. Some of the Pinecone or Wavy8 or VVLOS and FISS. And the database is the brain of our system. And next one is the semantic search. Once the embedding are stored, we can perform semantic search. This means the system looks for a meaningful matches. If the user asks a question later, the search engine will find the most relevant paragraph. So it does not relay the exact words. It relies on simply in meaning. This completes the data injection workflow we have successfully. So semantic search can collect documents, convert them into vectors, store them in a vector database. So made it searchable by meaning. Now let's move to the second workflow. Next we are going to the second topic of text generation workflow, answering the users. The text generation workflow, it is used to the user who gonna use the AI models or LLM models based on a RAG user. So this text generation workflow, it is used to answering the users. The text generation workflow, this part explains how the system take user questions and produce the final answer. Now let's go through the user input. Everything starts with the user typing a question. For example, explain the RAG architecture. This question enters the system. Now let's move the embedding model for query. Just like we converted document into vectors, we also convert the user questions into a vector. This helps the system compare questions vector with the document vector stored earlier. Now let's move to the query embedding. So now the user question also became list of numbers. By comparing these numbers with the stored vectors, the system can find the closest meaning. Next we are going with contextual retrieval. This is where the system searches the vector database, so it finds the most relevant paragraph, sentence or some sections. So these retrieval parts are called context. For example, if you ask about RAG, the system may retrieve the paragraph describing that are what RAG is, or how retrieval works, or how generation works. This context is the AI uses from the correct answers. Now we are going with the prompt arguments. Now the system combines the user questions, the retrieval context. This is combined input is called prompt argument. It tells the AI model, here is the user question and here is the important information you need to use and they generate the correct answer. Next we are going with large language models that are also called as LLMs. Finally, the LLM like ChatGPT or Llama or Collide or Mistral uses the questions, context and generate the final answer. This approach ensures the response so accurate and grounded in real data are reliable and explainable. This is how modern AI assistants, chatbots and enterprises search the system works. Now RAG works in two stages. Step 1 is data preparation. We take documents, convert them into a embedded and stored in a vector database, and also enable semantic search. The stage 2 is answering the generations. Convert user questions to embedded, retrieve and relevant context and combine the questions plus context and generate the final answer using LLM. RAG is powerful because it allows AI to use fresh, private and domain specific data, which LLM also cannot do. This is why RAG is widely used in customer support chatbots and enterprises such as document summarization, education assistant, medical and legally knowledge systems.